Up to this point, we've been working with mathematical relationships where we can express one variable explicitly in terms of another variable, right? Mainly functions where we can write y in terms of x, right? So like this equation, y equals the square root of x cubed plus 1, we have y on one side, and the other side of the equation is all written explicitly in terms of x. So all we need to do is put in the x value and we can calculate the y value. But there are some relationships that can only be expressed implicitly. So an implicit relationship is one where the dependent variable is not isolated on one side of the equation, right? So these would be implicit relationships down here, x squared plus y squared equals 25, right? So we don't have y in terms of x. We've got an equation with x squared and y squared on one side and a constant on the other side, right? We don't have one variable solved in terms of the other variable. Or sine of xy equals 3x squared y, right? And some relationships can only be expressed implicitly, well, both of these really. Now, this first one, x squared plus y squared equals 25, we could try to solve for y, but, you get y squared equals 25 minus x squared. And then to get y by itself, we'd have to take the square root of both sides. And when we do that, we would get the plus square root of 25 minus x squared and minus square root of 25 minus x squared. So really we end up with two equations to describe this one relationship. Okay, so there's no way to express y in terms of x explicitly as one equation, right? So this x squared plus y squared equals 25 is the only way you could write that relationship as one equation. And same way with this sine of xy equals 3x squared plus 3x squared times y. I mean, I don't know. I don't think you can even solve for y in terms of x. I'm not even going to try. So, but let's start by looking at example 1. We have this relationship x squared plus y squared equals 4. All right. So the first question is just asking us to figure out what curve in the xy plane is represented by this equation. Well, some of you might recognize the form of this equation, but if you don't, what you can do is just put in some values for x or some values for y and then solve for the other variables. So like, for example, if you put in, say, y equals 0, right? If you put in y equals 0, then you would end up getting either, you get x squared equals 4, so you would either get plus or minus 2, right? So we have a point, if I wanted to graph it over here, have a point at 2 comma 0 and negative 2 comma 0, right? I could do the same thing if I put x equals 0 in. And then when we solve for y, we'd either get y is 2 or y is negative 2, okay? So we have some points. Now, for any general xy coordinate, let's just say this is x comma y. The x is the distance that we go from the origin in the x direction, right? That's this. This is x. And y is the vertical direction. So I can draw y like this. Now, this is really just the Pythagorean theorem. We know that if we were to draw a right triangle here, right, because the x and y here are at right angles to each other, right? So if the hypotenuse of this triangle is x squared, the hypotenuse of the triangle is the square root of the x squared plus y squared, right? So x squared plus y squared, this has to be 4. Oops, no, it has to be 2, right? This has to be 2. This has to be 2, right? Because it's essentially the distance formula, right? I could take the square root of both sides and it would be the distance formula. So the distance from the origin to this point x, y has to be 2. And it's going to be 2 no matter what point you plot. And we know that that a circle is a set of all points that are the same distance from the center, right? Here the center would be 0. And so this implicit relationship describes a circle. All right, so I've drawn a circle here, and I've answered the question here. The graph is a circle with a radius of 2 centered at the origin, 0, 0, right? And that's just because this x squared plus y squared equals 4 describes all the points where the distance from the origin is 2, right? So all the points where the distance, all the points equidistant from the origin, 2 units from the origin would form a circle. All right, so let's look at the next question here. It says, explain in words why this equation does not represent an explicit function. It's not an explicit function because we can't solve for y in terms of x. If we tried to do that, we could get y squared is equal to 4 minus x squared, right? But then when I take the square root of both sides, I would get y equals the positive square root of 4 minus x squared, but I'd also have to keep in mind that that could be negative, so I could have the negative square root of 4 minus x squared. So y cannot be expressed explicitly as a function of x. Okay. All right. So now we also know the definition of a function as well, right? For a function, every input has to have exactly one output. So this is not even a function, right? It doesn't pass the vertical line test, right? There's, for one value of x, like for x equals 1, there would be a value down here and there would be another value up here. So you get 2 y values. So it's not even a function. All right, let's take a look at the next question. Find 2 points on the graph of this equation whose x value is 1. All right, well, let's do that. Let's do that. So I'm going to put in 1 for x. So I get 1 plus y squared equals 4, and then I can solve for y, right? I'll get y squared equals 3 if I subtract 1 from both sides. So that means that y is equal to either the plus or the minus square root of 3, right? So these points that I just drew up here, I would have 1 comma square root of 3 here. Down here I would have 1 comma minus square root of 3. Okay, so one x value gives 2 y values. All right, so let me write down those points so I can answer the question. We had 1 comma square root of 3, and the other point is 1 comma negative square root of 3. Okay. All right, let's look at the next question. Okay, this is a big question right here. Use the chain rule to differentiate both sides of this equation with respect to x and solve for dy dx. All right, this is where we get into implicit differentiation. All right, we're not going to have y on one side and an expression in terms of x on the other side. We can actually differentiate both sides of this equation using the chain rule. So remember, we have we're trying to differentiate. I'll write it this way: d dx of x squared plus y squared. And then the other side, we're going to differentiate that as well. We're going to take the derivative of 4. All right. Now, the first term here, over here on the left-hand side, is easy, right? If we take the derivative with respect to x, we're just going to get 2x. All right. That's easy enough. Now, the second term, there's no x there. There's no x there. What we have to do is consider y to be has some relationship with x. All right, and we're going to use the chain rule. So just treat y as if it's some sort of function of x, right? So the outside function is the square, right? And then inside of that is this y value that has some relationship to x. All right, so we treat it like a function of x. So I'm going to use a chain rule. The outside function is the square function. So what I'm going to get is 2y, right? I'm just going to use the power rule on it. But then remember, y is a different function. It's not it's x, right? So but it has some relationship to x. So what I'm going to do is multiply by the derivative of the inside function, which is dy dx. Okay? So we're using the chain rule here. Remember? So we're differentiating y squared. We get 2y, and then we have to multiply it by the derivative of the inside function, which is y. All right? Now, the other side is just a constant, so it's 0. So now we just need to solve for dy dx. Okay, so I'm going to subtract the 2x from both sides. I'm going to get 2y dy dx is equal to a minus 2x. All right, and then I just need to divide both sides by 2y. So if I divide both sides by 2 first, you can see those 2's will cancel. Divide that by 2, divide that by 2. And so my final answer will be dy dx, right? I'm just going to take that negative x and divide by y. So there's dy dx. There it is right there. That's dy dx. And we did that by differentiating implicitly. All right? We differentiated the function that was written implicitly. All right? Now notice we have dy dx, but it's in terms of both y and x though. So that's okay. That's okay. So let's look at the next question. For each of the 2 points you found in part C, find the slope of the tangent line to the curve at that point. And do your answers make sense? Okay. Well, first of all, the slope of the tangent line is just going to be the derivative at that point. Now the first point was, let's evaluate dy dx at the point, and sometimes we write a little line here, and the point is 1 comma square root 3. And so we're going to put in 1 for x and square root of 3 for y. Okay, so that's the slope of the tangent line at that point. And for the other point, dy dx at the other point, which is 1 comma negative square root 3, we're just going to plug in x and y. So we get negative 1 over negative square root 3, which is just equal to 1 over the square root of 3. So it's positive. All right, so the slope of the tangent line at 1 comma square root of 3 should be negative, and at the other point it should be positive. So let's go back and look at our picture up here and see if that makes sense. So I show those points. Oops, there we go. I show those points on here. And if I draw a tangent line, let me get a different color here. Let's see if I can draw a decent tangent line. Okay. Now it would make sense that that would be positive, right? That looks like a positive slope, and that's what we got. We saw that the slope of the tangent line was positive. And also, if I draw a tangent line here, okay, good enough. Looks like I could move it a little bit, but that's okay. But you can see it's sloping downward, so it makes sense that the slope of that tangent line is negative. So our answers make sense as far as the sign goes. And then it says find all the points on this curve where the tangent line is horizontal. Okay, now remember the tangent line is horizontal when the slope is 0. So let me go back to my green pen. So this just means the slope is 0. Okay, so the derivative will be 0. All right, well, our dy dx is the slope. So dy dx is equal to negative x over y, and we want to set that equal to 0. And that is only going to happen when the numerator is 0, right? So that's going to happen when x equals 0. Okay, so now we can find the points, we can find the y-coordinates of the points, because we got the x-coordinates, we can find the y-coordinates. Now we can just look at the graph too, because we can see from the graph what they should be. Or we could put 0 into our equation, 0 squared plus y squared equals 4. and we would get y is equal to either plus or minus 2. Okay, so the 2 points where the tangent line is horizontal would be 0, 0, 2 and 0, -2. Those would be our 2 points. Okay, and again, if we look at the graph of this circle, it would make sense, right? If we were to draw a tangent line at the top or the bottom of the circle, it looks like the tangent line would be horizontal, which means it has a slope of 0. So that makes sense. All right, and then it says find all the points on the curve where the tangent line is vertical. Okay, well, I guess I don't need to change color. So the tangent line is vertical. Remember, it's tangent. The slope is rise over run, and we end up with a vertical tangent line when we have all rise and no run. Okay, all rise and no run. So the slope would be undefined, right? So we want it to be undefined, and so that's going to happen when the y is 0. So that's going to happen when y is equal to 0, because the derivative is negative x over y, and so if y is 0, then the derivative would be undefined. So then we can find again, we could look at the we could look at the graph, or we could just say x squared plus 0 equals 4, and we find out that x would be plus or minus 2. Okay, so the points that where the tangent line is vertical would be 2, 0 and -2, 0. Okay. So again, we could look at the graph. Those are the points along the x-axis. Oops. And so if we were to draw a tangent line, either here or here, we'd get a vertical tangent line. So it makes sense. All right. That's all I have for this video, and I'll meet you in the next video for example 2.